Hello, welcome back once again. Today we have one of the hardest MIT integration B problem, right? The integral of 1 all over x to the power 4 plus 1 dx. So let's see how we're going to tackle this problem. Are we going to make a substitution? No, I don't think that is possible, right? But let's call this integral I first, okay? So our I is equal to the integral of 1 all over x raised to the power of 4 plus 1 dx, right? So this integral is same as we can divide the numerator by x squared, right? And also do the same thing at the denominator, which is x to the power of 4 plus 1, dividing this by x squared as well. And then we have our dx. Cool, right? Now, at the numerator, we're going to do the following. I is equal to, if we have 1 all over 2 right over here, then we're going to have 2 all over x to the power of 2, right? Yeah. Then we split the denominator into x to the power of 4 divided by x squared, and then plus 1 all over x squared, and then we have our dx. So this is equal to 1 over 2, then the integral of, so here this is same as 1 over x squared plus 1 over x squared. It is so because we have the same denominator, right? So we can easily add the numerators, which will give us 1 plus 1, which is 2, right? And here we're going to have x squared and then plus 1 all over x squared, and therefore we have our dx. Cool. I think this is getting more interesting, right? So what do you think we're going to do next from here? Now here comes the magic. We're going to do the following. Our I will be same as if we have 1 over 2 here, and then we have our integral sign. So we can do the following. Negative 1 plus 1 over x squared. But to balance this equation, to balance this expression here, as we can see right over here, we're going to have a positive 1 here, because we all know negative 1 plus 1, that is 0, and therefore we have 1 over x squared. So the numerator remains the same, right? And here we have x squared plus 1 all over x squared. It is time to split the denominator, and we're going to do that as follows. First, we have the following. I is equal to 1 over 2 times the integral of, so here we have 1 plus 1 over x squared. That is this one right over here, right? So we're going to split that denominator in that form, and then divided by x squared plus 1 over x squared, and then we have our dx, okay? Oh, so sorry for that. Oh my god. Okay, so here we're going to have plus 1 over 2 times the integral of, this is negative 1 plus 1 over x squared, and then divided by x squared plus 1 over x squared, and here we have our dx, right? Okay, cool. So from here we have this nice, right? We're going to do the following. This is 1 over 2 times the integral of, this is 1 plus 1 over x squared, and then divided by, so here this is x squared plus 1 over x squared, and then we have our dx. So here, if you factor out negative 1 from the numerator, which is going to make this as negative 1 over 2, then the integral, then we're going to have 1 minus 1 over x squared, because we factored out a negative 1, right? You get the point? So here we have 1 over x squared, and then we have our dx. Okay, so here comes our final magic when it comes to the algebraic manipulations here. So now let us recall this powerful identity in algebra. We know that a squared plus b squared is same as a plus b whole squared, right? Minus 2 times a times b. We also have that a squared plus b squared is equal to a minus b whole squared, right? Is that correct? Yeah. Then plus 2ab, right? Okay, so which of these denominator are we going to express in the first form, and which one are we going to express in the second form? And how exactly are we going to figure out? Okay, so now let's think about something like this. We know at the numerator here, as we can see, we have 1 plus 1 all over x squared. So if you think about expressing this denominator right over here in this form as the first one, so let's see what happens. Okay, so we have x squared plus 1 over x squared, which is same as x squared plus this is 1 over x whole squared. So expressing that, we get x plus 1 over x whole squared, right? Then minus 2ab, as we can see here, is going to be minus 2 times x times 1 over x, which is leaving us with only negative 2, right? Cool. And then we can as well use the second identity there, and then we express as x squared plus 1 over x squared. Then this is going to be x minus 1 over x whole squared, and then there will be a plus 2 here, right? Now let us put our I down right over here. So let us see what next to do. So here this is 1 over 2 times the integral of 1 plus 1 over x squared, and then divided by x squared plus 1 over x squared, and then we have our dx, and then minus 1 over 2 multiplied by the integral of this is 1 minus 1 over x squared, then divided by, right? Cool. Then divided by x squared plus 1 over x squared, and then dx. So for us to know if this denominator here should first be expressed like this or like this, we're going to take the derivative of this x plus 1 all over x, right? So if you take the derivative of x plus 1 all over x, derivative of x, that will give us 1. Cool. Derivative of 1 over x will give us negative 1 over x squared, which will give us negative 1 over x squared. And we can see that is what we have at this numerator right over here. So therefore, this denominator here will be expressed like this, because we know the derivative of this here will give us this one right over here, right? You get the idea? Okay, so let's do the needful now. So we're going to do the needful by doing the following. Okay, so our I is going to be equal to 1 over 2 times the integral of, so here we have 1 plus 1 over x squared, and then for this denominator here, that is going to be x minus 1 over x whole squared, and then plus 2, then dx, and here minus 1 over 2 times the integral of, so this is 1 minus 1 over x squared, and then divided by, so this is going to be x plus 1 over x whole squared, and then minus 2, and then we have our dx. So now we're going to make the following substitutions. For this first part here, this one right over here, we're going to let x minus 1 over x equals u. Differentiating both sides, oh sorry for this, so differentiating both sides, we're going to have 1, I think, yeah, then plus 1 over x squared dx, that this is equal to du. And for this part here, we're going to let x plus 1 over x equals v. Differentiating both sides, we get 1 minus 1 over x squared, as we can see at the numerator, is equal to dv. Therefore, our I is going to be equal to 1 over 2 times the integral, so we have du up here, then divided by, so this is going to be u squared, right, and then plus 2. Then here minus 1 over 2 times the integral of, so this is going to be dv all over, here we have v squared minus 2, and oh my god, we already have a dv, right? Oh, so sorry for that. Okay, my bad. Then let us take note of the following nice standard formulas. Okay, so we have the following. So we have that the integral of 1 over x squared plus a squared dx, that this is equal to 1 over a multiplied by the inverse tangent of x over a, and then plus c, and we have the opposition, right? X squared minus a squared dx, that this is equal to 1 over 2a multiplied by the natural log of x minus a, right? Then divided by x plus a, okay? Then plus c. Okay, so we're going to use this standard integral formulas here. So our I, remember, that is equal to 1 over 2 times the integral of 1 all over, so this is going to be u squared. Now plus 2 is same as square root of 2 whole squared, and then we have our du. So this is in this form, as we can see, right? X squared plus something squared, and here we have u squared plus something squared, and then minus 1 over 2 times the integral of, this is 1 over, so we have v squared minus, so 2 is same as square root of 2 whole squared, and then we have our dv. So this right over here is exactly in this form. So using those formulas, so we're going to have I is equal to, so this is going to be 1 over 2 multiplied by, so 1 over root of 2 multiplied by the inverse tangent of u all over root of 2, and then minus 1 over 2 multiplied by, this is going to be 1 over 2 times root 2, right? 2 times root 2 times the natural log of, so this is going to be v minus root of 2 divided by v plus root of 2, and then we have our constant of integration. Then let us recall back. We know u is equal to, so let's check. So u is equal to x minus 1 over x, right? So u is equal to x minus 1 over x, while v is equal to x plus 1 over x. Substituting, we get I is equal to, this is 1 over 2 root of 2 multiplied by the inverse tangent of u, which is x minus 1 over x, and then divided by the square root of 2, and then minus 1 over, so this is going to be 4 root of 2 from here, times the natural log of v x plus 1 over x minus root of 2 divided by x plus 1 over x plus root of 2, and then plus c. But we need to do further simplifications, right? So here, simplifying, we get I is equal to 1 over 2 root of 2 multiplied by the inverse tangent of, so here, multiply the numerator and the denominator by x. We're going to have x squared minus 1 divided by x root of 2, right? And then minus 1 all over 4 root of 2 times the natural log of, so here, if you multiply the numerator and the denominator by x, so we're going to have x squared plus, here, this is going to be 1, then minus x root of 2, cool, divided by, so this is going to be x squared plus 1, and then plus x root of 2. And then we have our plus c, and here is our final solution. Thank you for watching. Please, if you really enjoyed the video, please kindly subscribe to this channel. Support this channel by subscribing. Also like, comment and share.